Hello, friend, and welcome to the Sleepy Meteorologist. Tonight, we'll float gently into the soft, electric mystery of lightning. Not the startling kind that cracks across the sky with urgency, but the quiet kind. The kind that flickers behind a curtain of clouds, glowing faintly like a heartbeat in the heavens. Silent pulses on distant horizons. Gentle glimmers that never ask for attention, yet soothe the sky in passing. Maybe you've had a long day. Maybe you've heard too much, done too much, or simply carried more than you meant to. Now, the weight can ease. This is your moment to breathe. Outside your window, the weather might be humid or cool, clear or cloudy. Whatever the sky holds tonight, let it hold you too. No alerts, no noise, just the hush of atmosphere and the slow, glowing language of storms at rest. How's the sky looking where you are right now? If these gentle journeys through meteorology bring you peace, you're always welcome to like or subscribe, only if it feels calm to do so. Now, you can snuggle in. Let your thoughts settle like dew. Let's begin. Before the sky crackles or glows, before a single spark is seen by human eyes, lightning begins in a hush. It starts far above, where the clouds stretch tall into the atmosphere, billowing like quiet towers. Up there, where the air is thin and cool, water, droplets, and delicate ice crystals swirl together in an invisible ballet. As they collide, gently, silently, they transfer charge. Positives and negatives separate, slowly building an unseen tension within the cloud. There is no flash, no warning, just a patient accumulation, as if the sky is drawing a long, slow breath. This is the first stage, a kind of electric stillness. Within the heart of a thunderstorm, updrafts lift warm, moist air higher and higher, while downdrafts pull chilled air back down. These currents stir the cloud's interior, mixing its particles in soft yet persistent motion. Over time, these motions generate strong electrical fields. Still, everything remains cloaked in quiet. No one on the ground would guess what's building. The world below may seem peaceful, perhaps a still afternoon, perhaps a humid evening, where only the distant sound of cicadas hints at any tension. But above, charge is gathering, slowly, methodically. In time, the lower part of the cloud becomes heavy with negative charge, while the upper regions become positively charged. This separation creates the conditions for lightning to one day form. Yet, even now, it is all invisible. The cloud remains whole, unbroken. Sometimes, this quiet phase lasts for minutes. Other times, much longer. It is a phase of preparation. The sky is not rushing. There's no urgency here, just a measured atmospheric rhythm. This quiet build-up of energy, invisible to the naked eye, is the earliest whisper of a storm's eventual glow. It is the breath before the exhale, a softness before illumination. And in this silence, lightning waits. Even when the sky is clear and no storm cloud looms, the atmosphere is gently humming with electricity. Between earth and sky, there is always a faint electric field, subtle, quiet, ever present, like a breath held between two bodies. This natural electric field is part of Earth's global circuit. Our planet's surface carries a mild negative charge, while the upper atmosphere tends toward the positive. The air between them, even on cloudless days, is alive with quiet potential. You cannot see it, you cannot feel it, but it's there. This field is most noticeable during fair weather, when no storm interrupts it. It's like an unseen thread, stretching from ground to sky, maintained by thunderstorms happening elsewhere on the planet. Each lightning flash across the globe contributes to this gentle electrical hum. Imagine walking through a meadow under a wide blue sky. All seems calm, uneventful. And yet, high above, electrons are balancing, charges are drifting, and Earth's great electrical circuit continues, like a hidden heartbeat in the air. When a thunderstorm forms and charge builds inside a cloud, it alters this natural balance. The storm introduces a new electric field, far stronger, far more localized. The quiet background hum becomes focused energy, coiled and waiting. Still, there is no sound, no flash, just a shift in the air, far above. The sky feels thick. The light changes subtly. Birds may grow quiet. Insects pause. The atmosphere itself seems to lean in. This change is what makes lightning possible. It's not just about chaos, it's about balance too. The electric fields that exist above us, always there, always whispering, are the stage on which lightning eventually dances. And until that first flash, it all remains invisible. When we think of lightning, we often picture a bolt touching the ground, a sharp crack, a jagged line. But not all lightning seeks the earth. Much of it prefers to stay aloft, drifting cloud to cloud like a luminous river. These cloud-to-cloud flashes are called intra-cloud lightning. They meander through the sky's soft layers, flickering behind veils of vapor. Sometimes they trace long paths, tens of miles across, arcing like glowing tendrils through the upper air. Sometimes they branch and fork in hidden corners of the sky. From the ground, you may not see the bolt itself, but you might notice the result, a gentle, pulsing light behind the clouds, like a lantern softly glowing behind cotton. It brightens the sky from within, only for a moment. These intra-cloud paths form when charge differences build between different regions of the same cloud, or between neighboring clouds. Instead of grounding to the earth, the energy finds another pathway above. The atmosphere, layered and ever-shifting, allows these glowing bridges to form. They are part of the storm's quiet conversation with itself, a luminous breath, a threaded glow. On quiet summer nights, you might lie beneath a flickering sky and watch. These lights play. No thunder, no wind, just the dreamy dance of light moving silently between clouds. It is lightning, choosing to stay among the heavens. Sometimes, lightning doesn't reveal its sharp edges. It hides behind curtains of cloud, choosing not to strike, but to glow. This is sheet lightning, a broad, diffused illumination. You don't see the bolt, you see its presence. The cloud lights up in soft pulses, as if the sky is remembering something distant. The effect is peaceful, a flickering veil of silver and pale gold. Sheet lightning occurs when the flash is obscured by clouds, scattering the light in all directions. Instead of a single streak, the entire sky lights up gently. It's a luminous sigh. These glows can stretch across the horizon. They may repeat every few seconds, each pulse like a heartbeat. On warm nights, they illuminate the undersides of clouds, giving shape to the invisible architecture of the sky. There's something dreamy about it, like watching the sea reflect moonlight, but overhead. You might be lying in bed when you see it. Your room briefly lights up, then fades. No thunder arrives, just the soft suggestion of a storm far away, flickering kindly. Sheet lightning is a reminder that not all power needs to be loud. Sometimes, even storms prefer to whisper. And sometimes, the sky glows, just to glow. Before the eye ever sees the flash, before the thunder rolls, something delicate unfolds in the sky. A quiet preparation, a slow dance of invisible threads. They're called stepped leaders, tiny branching paths of negative charge that reach down from the cloud in a series of gentle, halted steps. Each pause, a decision. Each fork, a possibility. They descend toward the ground in stages, searching for a connection. These leaders move incredibly fast, but not in a continuous motion. Instead, they flicker forward in invisible frames, like a silent strobe in the sky. You don't see them, not yet, but they are there, feeling their way through the atmosphere. As they approach the Earth, a response begins from the ground. Objects below, trees, rooftops, open fields, begin sending up positive streamers. They reach up quietly, drawn to the descending thread. And then, somewhere, a meeting happens. One leader touches one streamer. That is the moment the full bolt forms, the bright return stroke that we finally see. But long before that flash, the sky was busy, making paths, weaving routes. It was a negotiation in silence. The stepped leaders don't rush. They explore. And when the right path is found, the sky exclaims in light. But until then, it only listens. And slowly, it dances. Once the stepped leader's path has reached down and found a match, an answering thread from Earth, something extraordinary happens. Quietly, completely, Earth responds. The return stroke travels upward along the channel the leader prepared. But unlike the slow, hesitant descent of the stepped leader, the return stroke is swift, racing back toward the cloud at nearly 1/3 the speed of light. It happens so quickly that we perceive it as instant, a sudden bright flash that lights up the world. But inside that moment, there is a story. This upward movement carries the energy release, the visible lightning bolt we know. Yet even with all its brilliance, it remains part of a gentle conversation between cloud and Earth. The flash is brief, the energy immense, but the moment passes just as fast as it arrives. The heat from this return stroke can be intense. Air surrounding the bolt expands so rapidly that it creates the soft rumble we call thunder. But the bolt itself, for all its speed and brightness, is part of a natural cycle, a balance being restored, a calm release. One might imagine it not as destruction, but as a transfer of understanding between sky and land. From the ground, the world may pause. You might feel it more than see it. A hush in the wind, a pause in the rain, a change in the scent of the air. Trees may tremble gently, as though they too heard the sky speak. These return strokes don't always come alone. Sometimes, after the first flash, the same path is used again, multiple strokes following in rapid succession, reusing the same invisible thread. They are called subsequent strokes, and though we may see them as one flickering moment, they are in fact many. A flicker, a breath, a reply. The sky is speaking, but never in haste. It sends its energy back through the waiting channel, like a message whispered up through silver threads. And Earth receives it, not with resistance, but with understanding. In sleep, we often imagine illumination as something sudden, something sharp. But in the natural world, illumination can be quiet. It can be shared. The return stroke is not just energy, it's a response. It's completion. It's a breath out after a long, invisible inhale. And when it's done, the clouds may continue drifting. The rain may fall more softly. The sky may even clear briefly. For a moment, something has been resolved. The sky exhaled. The earth replied. And now the quiet returns. Thunder may sound powerful, but at its heart, it's born from something delicate, warmth stretching too quickly. After lightning flashes, the air around it is suddenly impossibly hot, reaching temperatures hotter than the surface of the sun. And this sudden heat forces the surrounding air to expand. Not slowly, not carefully, but all at once. This expansion creates a ripple, a pressure wave. That wave moves outward in every direction, and we hear it as thunder. But the way we hear it depends on where we are, how far we are from the lightning, and what the sky around us is doing. Sometimes it cracks, sometimes it rolls, sometimes it's a soft murmur just above the treetops. To us, thunder might feel like a sound of power, but in truth, it's the sky stretching after being surprised by its own brightness. It's the sigh of the atmosphere, adjusting to what just occurred, and it tells us not of danger, but of distance. Count the seconds between flash and sound, and you'll learn how far the storm has travelled, roughly 5 seconds per mile. This simple timing makes the sky feel more personal, as if it's letting us in on a secret. Sometimes the storm is close, and the thunder arrives quickly. Other times, it wanders slowly across hills and rooftops, and in rare cases, you may see the flash, but hear no thunder at all. That means the sound has scattered or faded before reaching you. In valleys, thunder echoes. In wide open plains, it rolls forever. In forests, it muffles into the leaves. Wherever you are, the sound reshapes itself to the space. At night, when the world is quieter, thunder becomes something else. A lullaby from a sky still flickering. A murmur that doesn't intrude, but gently reminds. Thunder is memory. It is the air recalling what lightning just did. It is not the loudness that matters. It is the echo, the softness, the story whispered through air. And so, when you hear thunder tonight, you need not brace. You can simply listen and let the sky tell you it remembers. Sometimes the storm is too far away to touch. The air remains dry, the wind is still, and yet, above you, a flicker of light appears in the sky. Silent, distant, beautiful. This is lightning without rain. Also called dry lightning, it's a quiet, wandering phenomenon. No raindrops fall, no thunder rolls across the hills. But the sky is alive nonetheless, alive with light that travels beyond the boundaries of a storm. This kind of lightning often happens when storms form in high, dry air. Rain may fall inside the cloud, but by the time it reaches lower altitudes, it evaporates, leaving only the lightning to continue its journey. From the ground, we see the flicker. From the sky, the storm is doing its work. Dry lightning often occurs in arid regions or during long stretches of heat. In desert climates, it's especially common, but it can also appear in temperate places, as long as the air is dry enough to let the rain vanish before reaching us. These distant illuminations feel almost like echoes, like someone lighting a lantern far down a hallway, its glow gently reaching you, even if its warmth does not. You may be walking at dusk or resting in bed when you see it. The stars are out, the world is quiet, and then, softly, the sky glows. No sound follows, no rain dots the windows, just that brief, glowing signature of a storm that remains far away. Some people say this kind of lightning feels more mysterious, even haunting. But in our soft nighttime journey, it becomes something else entirely. A reminder that the sky is always active, always reaching, always glowing somewhere, even when our corner of the world is still. You might feel small beneath it, but not insignificant, because even without sound or touch, the storm sends its light your way, like a memory, like a signal, like a whisper. Dry lightning is a conversation that doesn't need words. It's the gentle promise that the atmosphere is always in motion, and that light, even when it travels alone, is never truly lost. So, if you find yourself beneath a dry sky and see that flicker above you, don't search for thunder. Don't wait for rain. Let it be what it is. A moment of illumination, a quiet companion, a flash of distant weather passing through your night. There's an old saying that lightning never strikes the same place twice, but the clouds know better. In truth, lightning often returns to familiar places, not because of randomness, but because the conditions invite it. Tall structures, solitary trees, towering cliffs. These places stretch upward into the charged air, closer to the source, closer to the sky's reach. To the sky, some places are simply easier to touch. Take a mountain peak, or the spire of a cathedral, or the steel arms of a broadcast tower. These objects don't call down lightning, but they don't resist it either. They extend quietly into the electric fields, standing tall and patient. Lightning finds them not out of anger, but familiarity. There's a rhythm to it, a quiet routine. The Empire State Building, for instance, is struck dozens of times each year, but not in fury, in resonance, like a bell being rung by the sky. When lightning returns to the same place, it's not defying expectation. It's following the path of least resistance, and that path is shaped by structure, by altitude, and by quiet invitation. There's something comforting in that, isn't there? The idea that the sky remembers where it's been, that it returns to places it knows. We often think of lightning as wild, unpredictable, but it's more graceful than that, more methodical, more aware. If you've ever stood in the same spot during multiple storms, you may notice it, how the light seems to favor one tree, one ridge, one rooftop, as if the sky is reaching for an old friend. And while the term strike implies violence, the truth can be gentler. The bolt is fast, yes. Bright, yes. But it's not vindictive. It's not cruel. It is simply energy completing a circuit. And when it finds the right place, it returns, again and again. So, perhaps the saying needs a rewrite. Lightning does strike twice, and sometimes it does so with quiet grace. It visits, it remembers, it completes what was started, and then it moves on. On a still summer night, when the air feels thick and the cicadas hum softly, you may look out across the horizon and see something flicker. A light, brief and pulsing. It glows, then vanishes. This is heat lightning. Despite its name, it isn't born from heat itself. It's just regular lightning from a distant thunderstorm, too far away for its sound to reach you. The conditions of warm summer nights help carry the light farther, across wide fields and quiet skies. The storm might be 50 miles away, or more, hidden behind hills or buried in clouds. And yet, you see the evidence of it, the soft flash, the brief glow. It feels like a secret, doesn't it? A message from beyond the trees, a soft conversation between storm and stars. These flashes don't need thunder. They don't demand your attention. They simply arrive. A reminder that somewhere, beyond your view, the sky is speaking, and you've caught a glimpse. Heat lightning feels nostalgic somehow, like an echo from childhood, like nights spent lying on the porch, watching the sky shimmer without fear. There's no sound to startle you, just a flicker to make you wonder. Is someone else watching it too, from the other side of the storm? It's comforting in its way, proof that even distant storms have beauty, that not all power must roar. Some of it glows gently, at the edge of our vision. So, if you find yourself outside some humid evening and you see the sky flicker in silence, let it be a gentle reminder. Even storms that pass far away can share their light with you. And even in the quietest nights, the sky still hums with wonder. High in the sky, where the upper reaches of a thundercloud flatten into a wide, spreading canopy, a special kind of lightning begins to wander. It doesn't rush downward or strike in a sudden jolt. Instead, it drifts sideways, gliding across the sky in a patient, glowing crawl. These are anvil crawlers, named for the shape of the cloud they inhabit, the broad, flat anvil top of a cumulonimbus. They trace delicate, luminous lines along the upper edges of the storm. Sometimes they travel for tens of miles, fingers of light creeping slowly through the air, illuminating the sky in irregular, dreamy pulses. They don't always make contact with the ground. In fact, they often seem detached from the world below, choosing to explore the vaulted ceiling of the sky. They emerge from the storm's upper levels, lighting up vast arcs like a spiderweb of electricity, gliding across an unseen dome. From the ground, they are mesmerizing. Their movement is slow by lightning standards, and their paths are intricate, like glowing veins threading through the atmosphere. These bolts often appear in clusters, with several crawlers branching outward, each one softly illuminating the interior of the storm cloud, like a lantern passed behind silk. Unlike cloud-to-ground lightning, which can be brief and sharp, anvil crawlers have a layered rhythm. They linger, they stretch, they appear to wander thoughtfully, as though the sky is writing in cursive with a pen of light. They're more likely to appear during mature thunderstorms, especially those with strong updrafts and broad storm tops that have spread horizontally. And they are often associated with positive lightning, which carries stronger charge and can travel farther than typical negative strokes. Sometimes you may see an anvil crawler during a nighttime storm when the world is hushed and the clouds loom large over quiet fields or sleeping cities. The crawler flashes, branching outward as if touching the very edges of the storm's thoughts. You may not hear thunder right away, or at all, but the light makes itself known. There's something meditative about watching them. Unlike bolts that shout, these ones whisper. They take their time. They seem content to travel slowly, without hurry, leaving glowing trails that fade like memories. In their quiet beauty, anvil crawlers remind us that not all lightning must be sudden or loud. Some can be graceful, wandering, dreamlike. The sky, after all, contains many moods, and sometimes it chooses to crawl, not strike. Snowstorms are typically associated with silence. The way snow falls softly, muffling the world below, brings a hush to everything it touches. And yet, in rare and wonderful moments, that stillness is interrupted by a flicker. This is thunder's now, a lightning flash in the heart of a winter storm. It's a rare event, but when it happens, the contrast is unforgettable. The sky glows bright for a moment, and the snow, falling gently through the light, seems to shimmer like stars suspended in a snow globe. Thunder snow happens when the same conditions that generate summer thunderstorms, instability, moisture, and lift, arise within a cold environment. The result is a winter storm with just enough vertical energy to spark a flash. The snow reflects and amplifies the light, making each bolt feel even brighter. Instead of lighting up the sky alone, the lightning dances through curtains of white, illuminating billions of tiny crystals as they descend. The result is magical, light wrapped in snow. Thunder often sounds different in these storms. The snow absorbs and softens the sound, turning what might otherwise be a sharp crack into a muffled roll. It feels distant, yet near, like a sky trying not to disturb the peace. You may be indoors when it happens, tucked beneath blankets, watching snow fall beneath streetlights. Then, without warning, the world turns white, just for a second, as if a camera flash had lit up the entire sky. It's a quiet kind of wonder. Meteorologists often marvel at thundersnow, not only for its rarity, but for the way it blurs seasonal boundaries. It's a summer storm's heart, beating within a winter body, a spark of warmth inside a blanket of cold. There's something poetic about that, a reminder that even in the quietest of seasons, electricity still hums. That lightning, though usually loud and bright, can also choose to be soft and wintry. And when it does, it gives us the rarest gift of all, light falling gently through snow. Lightning is not limited to storms. It can be found in one of Earth's most powerful displays, volcanic eruptions. Volcano lightning, also called dirty thunderstorm lightning, occurs when a volcano sends clouds of ash, rock, and gas high into the sky. Within that plume, an unseen drama unfolds. Particles rub against one another, building static charge in much the same way as water and ice do in thunderclouds. As ash rises, friction grows. Particles collide, separate, and shuffle their charges like cards being mixed. Eventually, the differences become too great, and the air can no longer hold the tension. Lightning is born not from clouds, but from ash. The result is spectacular. Bolts thread themselves through the dark plume like glowing veins. Sometimes they flash high above the volcano, illuminating the sky above the eruption. Other times, they remain close to the summit, their light diffused by smoke and ash. Volcano lightning often feels primal, ancient, a reminder that Earth itself holds power equal to the sky, that the ground too can spark and glow. It's more common in large eruptions, ones that produce tall, dense ash columns. But even smaller eruptions can create it, especially when the air is dry and particles are plentiful. There's no thunderstorm in the traditional sense, no cumulonimbus, no anvil top, only a mountain exhaling fire and the sky answering back with light. The visual contrast is stunning. Dark ash, bright lightning, a dance of shadow and spark. In mythology, lightning has often been tied to the divine, to gods of the sky or mountains. When you watch lightning curl through volcanic ash, you begin to understand why. It feels elemental. Yet, for all its power, it is born from simple collisions, dust and debris, brushing together in a plume. Even in chaos, there is beauty. Even in ash, there is light. And sometimes, Earth reminds the sky that it can shine too. Hurricanes are often imagined as vast, swirling engines, wind, rain, and pressure, spiraling around a quiet center. But deep inside these powerful systems, another phenomenon pulses softly. Lightning. It doesn't dominate the storm. It doesn't appear constantly. But when it does, it tells a story about the storm's strength and structure. Lightning inside hurricanes is a quiet flicker within a giant breath, like a heartbeat within a slumbering body. Unlike in typical thunderstorms, where lightning flashes frequently and boldly, hurricane lightning tends to stay tucked within the storm's inner bands, or near the eye wall. These regions contain towering clouds, called hot towers, columns of rapidly rising warm, moist air that punch upward with energy. Within those towers, familiar things happen. Water droplets rise, ice particles form, and charges separate. And just like in other storms, that charge can build until it leaps, creating a brief pulse of light. From the ground, it's rarely visible. The hurricane structure is thick and layered, and lightning often hides behind its walls of rain and cloud. But from above, or detected by satellites, these hidden flashes become traceable. Tiny blinks revealing moments of intensity deep within the storm. What makes hurricane lightning so compelling is its quiet placement in an otherwise chaotic environment. While winds howl and rain lashes, these flickers remain internal, almost private. They don't seek the ground. They don't branch outward in dramatic forks. They shimmer like whispers. Meteorologists pay close attention to this lightning. Its presence near the eye can indicate strengthening, signals that the storm is drawing more heat and moisture from the ocean, that its structure is tightening, that its heart is becoming more focused. In this way, hurricane lightning is both signal and symptom, not a warning to fear, but a whisper of what's unfolding deep within. Some hurricanes flash more than others. Some remain quiet their entire journey. But when lightning does appear, it reminds us that within every great rotation, small stories are happening. Each flicker is a dialogue between particles, a quick negotiation of charge, a flash of balance in the spiral. Imagine standing far from shore, watching clouds swirl over distant water. The storm is out there, far away, and the sky above you is still. Then, just barely, a flicker, a pause, then darkness again. That single light might be the storm's breath, its voice, its quiet presence reminding you that even in the largest of storms, energy is always shifting. Not all lightning is loud, not all storms shout, some simply pulse from within. The sea is often seen as a calming presence, wide, rhythmic, and endlessly blue. But it too feels the sky's electricity. Lightning doesn't ignore the ocean. It touches it gently, briefly, before moving on. When lightning strikes the sea, it behaves differently than it does on land. Water, especially salty water, is an excellent conductor. So, instead of diving deep, the electrical energy spreads out across the surface, like ripples on a mirror. The bolt lights the air above and grazes the ocean's skin. Its brightness is visible for miles. But the sea doesn't resist. It receives the bolt quietly. The current disperses rapidly, moving outward more than downward. Contrary to popular worry, marine animals rarely feel this energy. Fish swim below the strike zone. The charge doesn't travel deep. Sea turtles, dolphins, whales, they are almost always safe, cocooned in the deeper, cooler layers below. From the shoreline, a lightning strike on water can appear elegant, a vertical thread of silver reaching down into the vast unknown, sometimes followed by steam, sometimes by nothing but light. Sailors and mariners learn to watch for these signs. Lightning over the sea often reflects in the waves, doubling its beauty. A bolt may split the sky, and its twin will shimmer below, momentarily illuminating the horizon. Storms over water move differently, guided by air pressure and ocean heat. Sometimes they form squall lines, narrow, fast-moving bands of thunderclouds that trail arcs of light behind them. And in their midst, a bolt may choose the sea as its destination, but it never stays. The ocean is too fluid, too welcoming. The energy glides along the surface and fades. For those aboard ships, safety lies in enclosed spaces, in hulls that redirect charge. For those on shore, it's a reminder of nature's reach, the way lightning can find even the farthest, flattest places and still deliver its touch. Yet even here, it doesn't harm without cause. It illuminates more than it disrupts. So next time you look out at the sea during a summer storm, watch the horizon. A flicker may come, brief, bright, gone, a moment of sky meeting sea, and then only the waves remain. When lightning searches for a place to land, it often chooses the path of least resistance. And in many cases, that means reaching for what's already reaching up, the tallest object in the area. A lone tree in an open field, a church steeple against a grey sky, a transmission tower standing still beneath thick clouds. These become the meeting points between ground and sky. Not because they call lightning down, but because they're already halfway there. Electricity seeks the shortest route. In a charged atmosphere, with negative particles gathering below the cloud and positive ones rising from the ground, something in between becomes the bridge. Tall things don't summon lightning. They simply become the easiest way for the atmosphere to connect its charges. But even then, lightning doesn't always follow a straight line. Sometimes it curves gently, sideways, angled like a question mark. Lightning is not bound by our expectations. It travels through air like a seeker, choosing paths shaped by temperature, humidity, terrain, and wind. There have been moments when people saw a bolt travel miles horizontally before touching down, skimming just beneath the cloud base before gracefully descending. These are called side flashes or ground flashes, and they can surprise even seasoned storm watchers. In mountainous regions, ridgelines become familiar targets. In cities, skyscrapers often wear the memory of past strikes. And yet, sometimes a bolt bends past them to find something unexpected, a crane, a chimney, or even open ground. The path lightning takes is not always visible until it finishes its journey. What we see as one brilliant bolt is the result of invisible preparation, stepped leaders exploring downward, streamers reaching up, all converging into a single moment of connection. In this way, lightning isn't simply a fall from above, it's a meeting in the middle. And tall things, by their nature, are already leaning into that meeting. It's worth noting that lightning protection systems on buildings and towers don't stop lightning from striking. They guide it safely to the ground. They accept the sky's touch and help deliver it gently, away from harm. When you next look out at a landscape, city, forest, or hillside, consider the forms that rise. These become the atmosphere's fingertips. They are not just structures or silhouettes. In a charged sky, they are invitations. Not every tall thing gets touched, but when the sky is ready, it knows where to reach. And sometimes it reaches farther than we expect. Because lightning, like curiosity, doesn't always follow the straightest path. It follows the one that feels right. When we think of lightning, we often imagine towering thunderclouds and rainy skies. But the spark of lightning can also emerge from unexpected places. Places without water, without thunder, without the classic stormy soundtrack. Volcanoes, dust storms, even intense wildfires. In these environments, it's not water droplets and ice that build charge, but ash, soot, and dust. Tiny particles collide and rub against each other in chaotic motion. Friction builds, charges separate, and eventually the same invisible tension forms, begging for release. Volcano lightning, as we've seen before, is dramatic and mesmerizing. Bolts twist through ash plumes like glowing roots in dark soil. But dust storms, especially in desert regions, can do the same. As wind sweeps up particles into the air, sand, debris, organic matter, those elements grind together, slowly building a charge. At first, there's only motion, then a flicker. These events are dry. There's no rain to soften the landscape. The light appears stark, sometimes silent, especially when viewed from a distance. It may flash just once, or it may repeat, over and over, like a storm conjured from Earth itself. In large-scale dust events, like haboobs or sandstorms, the buildup can be significant. The entire leading edge of the storm can glow with scattered discharges, tiny zaps hidden in the dust. Pilots flying near these phenomena sometimes report seeing arcs dance between grains of sand as the storm front passes. Wildfires, too, can create their own lightning. As the heat from intense fires drives air upward, smoke and ash mix violently. The plume mimics a thundercloud, and within it, charges can form. Lightning becomes possible, not from the sky's cold anger, but from the Earth's burning breath. In all these cases, the ingredients are different, but the outcome is familiar. Lightning reminds us that it doesn't need thunderclouds to exist. It only needs energy, movement, friction, separation, and time. So whether it's in a desert, a forest fire, or the ash cloud of a distant volcano, the spark can still form. It may be brief, it may be rare, but when it comes, it connects the unseen threads between motion and glow. And in doing so, it reminds us, the sky doesn't own lightning, the Earth does too. Not all lightning wants to strike. Some prefer to stretch. Spider lightning, with its wide-reaching arms, is one of the most elegant forms of this phenomenon. Rather than diving toward the Earth, it spreads across the sky, gliding horizontally in long, glowing paths that resemble threads of silver silk. These horizontal discharges can stretch for over 100 kilometers, moving slowly compared to typical flashes. They weave through the sky, often trailing behind a fading bolt or branching outward from an earlier strike. They may seem playful, delicate, but they're full of energy. Spider. Lightning usually occurs in the upper regions of storm clouds, particularly in decaying or mature storms, when conditions are just right. There's less vertical instability, so the energy travels outward, seeking space. From the ground, it's breathtaking. The bolt flashes across the whole sky, horizon to horizon. Sometimes it's white, sometimes tinged with blue or violet. Each flicker traces the edge of the storm's thoughts. These bolts rarely come with thunder. Their sound may be too far to reach you, but their presence is unmistakable, like illuminated handwriting above the world. People have described it as skywriting in electric ink, and it does feel personal, like the clouds have something to say. The spider name comes from its appearance, low, wide, and branching, but there's no fear in this spider, no menace, just motion, a slow, shimmering glide across a soft canvas, and then, as quickly as it appeared, it fades, leaving only awe and silence. Sometimes, lightning chooses to stay hidden, tucked within the body of a cloud, never reaching toward the ground or stretching across the sky. Instead, it pulses quietly from within. This is intracloud lightning, and when we watch it from a distance, it looks like veins of light glowing behind a curtain. You might see it on a summer night when thick cumulonimbus clouds drift across the horizon. The air is still, the sky is heavy, and then a flash, soft and brief. The cloud brightens from within, its entire body illuminated for just a moment. No bolt, no path, just light curling inside. The effect is mesmerizing. Lightning branches and pulses inside the vapor, tracing invisible patterns. It moves like electricity through a living body, like blood vessels illuminated by X-ray light. These aren't the harsh zaps we associate with danger. They're more like whispers of light behind the sky's skin. Intracloud lightning is the most common type of lightning, though we often don't notice it. Unlike cloud-to-ground strikes that demand attention, these flashes speak softly. They unfold within the cloud's interior, following the complex pathways of charge between regions we'll never see. A thundercloud is layered and alive. Inside it, warm air rises and cool air sinks. Moisture condenses. Ice crystals collide. All of this motion creates friction, and with it, separation of charge. Positive at the top, negative below, or sometimes reversed. That imbalance, held quietly within the cloud's form, builds and builds. When it finally becomes too great, the cloud resolves it. A pulse arcs from one region to another, equalizing the imbalance. But unlike a strike that jumps to the earth, this one stays enclosed. A cloud flickers, glows, fades. From a distance, you may feel like you're watching a living thing breathe. The pulses are irregular. Some are bright and quick, others slow and dim. You may sit watching for several minutes, the cloud flashing softly again and again. Each one a private conversation within the sky. Thunder often follows, but like the light, it's muted. You might hear a low rumble, or nothing at all. The sound becomes part of the landscape, a hush moving through treetops, across fields, over rooftops. At night, the show is even more striking. The dark sky becomes a canvas, and each hidden flash adds shape to the cloud's silhouette. You begin to see the edges, the layers, the swelling form of the storm, revealed one quiet flicker at a time. This is the sky's inner world, glowing just for a moment. Veins of light, hidden motion, unseen balance. And when the cloud has said what it needed to say, the sky goes dark again, still, waiting. When you see lightning, it might seem like a single, instant event, a quick streak of light, here and gone. But in truth, a lightning bolt is almost never just one flash. It's a layered, rapid dance of multiple pulses, all following the same path. This phenomenon is known as a multiple stroke flash. What appears to be a single bolt is often 5, 10, or even 20 return strokes occurring within fractions of a second. Each one retraces the ionized channel carved by the first, refreshing its light, echoing its path. Your eye may see one long flicker, but it's actually a stack of separate pulses, like footsteps repeating on the same trail. The process begins with a stepped leader, a faint, downward-moving path of charge. When it finds a connection near the ground, the return stroke races upward along that path, and light floods the sky. But that's only the beginning. Residual charge still exists, so milliseconds later, more strokes follow, using the same channel. These subsequent strokes are slightly dimmer and faster than the first, but they add layers of light, sometimes giving the appearance of a strobe or flicker. This explains why some lightning seems to shimmer or vibrate, why it doesn't simply flash and disappear. The atmosphere is not finished after one exchange. It often needs several. Each pulse is a quiet refinement, a final reply, and the sky allows it. High-speed cameras have revealed the complexity of these strikes. What once seemed simple becomes a masterpiece of repetition. Arcs and subarcs, ground strokes and branches. A choreography too fast for human eyes to follow, but real nonetheless. Even the sound reflects this. Thunder is not just one boom. It rolls because the strokes come in waves. Each one adds to the air's expansion, layering the sound like an unfolding story. Some flashes also feature what's called a continuing current. In these, a soft glow lingers in the channel between pulses, keeping it faintly lit as the next stroke prepares. From the ground, you may see a bolt that doesn't just flash, but glows, a slow burn instead of a blink. It's important to remember, lightning is not impatient. It is thorough. It completes its circuit fully, repeatedly, until the charge is spent. So, the next time you see a lightning bolt, know that what you witnessed was not a single moment. It was a layered reply, a series of breaths, a rhythm in the sky. And then the dark returns. Not because the sky has nothing left to say, but because, for now, it has said enough. Lightning may appear in an instant, but within that flash is a journey, a swift and complex one. To the eye, it seems like a sudden burst, a blink of brilliance. But behind that moment is a dance of motion, with speeds that boggle the mind. The stepped leader, the first path of the lightning strike, travels downward from the cloud in small segments, each step just tens of meters long. These steps occur at intervals of millionths of a second, giving the appearance of hesitation, like a hand feeling its way in the dark. Even this cautious descent moves fast, up to 220,000 kilometers per hour. Then, the moment of connection. When the stepped leader meets a rising streamer from the ground, the return stroke begins. This is what we see as the bright bolt, the dazzling flash that lights the world around us. The return stroke doesn't creep, it races. At nearly 1/3 the speed of light, it surges upward along the leader's path, illuminating the ionized channel in a brilliant display. That's about 100,000 kilometers per second, fast enough to travel from Earth to the Moon in less than 4 seconds. This is why the bolt appears instant, why it seems to come from nowhere. The speed of light defines our visual perception, and lightning rides the edge of it. But it's not just the return stroke. Even within the bolt, subcomponents, called dart leaders and subsequent strokes, follow rapidly. The strike is a relay of electrical surges, each moving through a pre-lit path, like runners exchanging glowing torches. The entire process, from the first leader to the last stroke, typically lasts under a second. And yet, in that brief time, the atmosphere is changed. Energy is moved. Balance is restored. You may see only the flash, but inside that flash is a tale of velocity, precision, and purpose. The sound arrives later. Thunder lags behind, reminding us that light outruns all else. A reminder that even in the natural world, some messages reach us before others. So, next time you glimpse a lightning bolt, know that you're watching the atmosphere make a decision and act on it at astonishing speed. And all of it, somehow, feels peaceful once the glow fades. You may be standing under sunshine. The sky above you is blue. No clouds, no warning. And then, lightning. It seems impossible, but it's real. These rare events are known as bolts from the blue, a poetic name for a startling phenomenon. They occur when lightning originates from the upper parts of a thunderstorm, often the anvil-shaped top, and travels horizontally before striking the ground far away from the storm itself. How far? Sometimes more than 25 kilometers. That's over 15 miles. The storm may be out of sight. It may seem to have passed, but its electric presence lingers, and lightning, ever mysterious, sometimes chooses to reach farther than we expect. These bolts are often stronger than typical strikes. Because they travel such long distances through clear air, their charge remains focused, unscattered by rain or turbulence. When they land, they do so with force. They're more likely during the mature or dissipating stage of a storm, when the upper levels remain charged, even as the lower clouds begin to fall apart. From the ground, they are surprising. There's no towering cloud above you, no thunder rumbling in the distance, just a sudden streak of light and a sharp crack. To meteorologists, this reinforces an important truth. If you can hear thunder, you're within reach of lightning, even if the sky looks calm. But for us, in this quiet space of curiosity, bolts from the blue remind us of something gentler, that the sky is vast and its energy flows in unexpected ways. A storm doesn't always announce itself at your doorstep. Sometimes it reaches across the landscape like a hand extended from afar, like a memory not yet gone, like a whisper that arrives long after the voice. And when it does, we are reminded, never assume the sky is finished speaking, just because it looks clear. Each lightning bolt carries extraordinary energy. Within that brilliant flash is the power to illuminate, not metaphorically, but literally. Roughly 1 billion joules of energy pulse through a typical lightning strike. That's enough to power a small town, thousands of homes, for a few brief moments. Imagine it, a single arc of electricity, less than an inch wide, transferring as much energy as it would take to run a refrigerator for a month. A city block of lights, a bank of heaters. The power is immense, and yet most of it is spent in an instant, dissipated as heat, light, and sound. The atmosphere receives it, the ground absorbs it, the air expands, glows, and settles. For this reason, efforts have been made to harness lightning's power. Could we store it, direct it, convert its energy for human use? But the challenge is timing. Controlling something that appears for less than a second without warning is no small task. The current of a lightning bolt can reach 30,000 amps, the voltage up to 1 billion volts. These numbers defy our typical measurements. They belong to a scale beyond daily life. Yet, you might feel it in smaller ways. The flicker of a bulb, the buzz of electronics. Lightning can induce electromagnetic waves that ripple through the ground and power lines. We notice it in blinks and beeps, reminders of distant energy passing through. Some strikes cause blackouts, others pass harmlessly into soil, but everyone carries that same potential, the spark of illumination, brief, brilliant, gone. Lightning is nature's reminder that energy is everywhere, waiting, gathering, releasing. We don't need to harness it to be in awe of it. Sometimes, just knowing that a single bolt could light the world for a breath is wonder enough. Of all the luminous phenomena in the sky, few are as puzzling, or as whispered about, as ball lightning. Unlike the sharp forks of regular lightning, or the slow drift of spider lightning, ball lightning appears as a glowing orb, a sphere of light, usually the size of a grapefruit, floating silently, calmly, and unpredictably. It may hover above the ground. It may drift through open air. Some say it passes through walls or windows, and almost always it vanishes without a trace. Accounts of ball lightning go back centuries. Farmers, sailors, pilots, even scientists have described seeing glowing orbs during or after thunderstorms. Some report it hovering for several seconds. Others say it floated along a path, spinning slowly, pulsing like a heart. In rare stories, it hissed softly or popped before fading. But most often, it simply disappeared. A dream made of static. Despite all the stories, ball lightning remains elusive to science. There's no universal explanation. It defies replication. It doesn't appear on demand. It arrives quietly, often when the sky has already begun to calm. Some theories suggest it's a plasma-based phenomenon, a ball of ionized gas held together by magnetic fields. Others propose a chemical reaction involving silicon vaporized by a lightning strike. Still others think it's an illusion, a trick of the eye created by atmospheric reflections or afterimages. But whatever the cause, those who've seen it rarely forget. Imagine sitting by a window after a storm. The rain has eased. The air is damp and still. Then, without sound, a small orb of golden light appears, hovering just above the grass. It doesn't flash, it glows, as if the storm left behind one last breath of itself. Or picture a ship at sea, with lightning striking the ocean nearby. And suddenly, a sphere of blue light floats above the deck, held in the hush between waves. Some sightings are dramatic, others feel intimate. A moment of wonder that doesn't try to explain itself. There have been attempts to study it, photographs claimed, experiments designed. But still, ball lightning resists the spotlight. It prefers mystery. It prefers folklore. And perhaps that's part of its charm. Not everything in nature offers a quick answer. Some things are meant to remain strange, beautiful, dreamlike. So when we speak of ball lightning, we speak not only of light, but of imagination, of the places where science and story intertwine. Was it real? Perhaps. Was it dreamed? Maybe. But either way, it reminds us that even after the storm has passed, something luminous may still linger. When lightning strikes, it doesn't just light the sky, it heats it. In fact, for the briefest instant, a lightning bolt becomes one of the hottest things in the known world. Temperatures inside a lightning channel can reach around 30,000 degrees Celsius. That's 5 times hotter than the surface of the sun. This extraordinary heat is not sustained. It lasts for less than a second, just long enough to split the air apart and create the flash we see. The rapid expansion of heated air is what causes thunder. The light arrives first, but the sound follows close behind, rippling through the atmosphere like a slow exhale. Despite its temperature, lightning does not leave trails of scorched earth wherever it lands. Most of its energy remains in the sky, and the heat dissipates almost immediately. It's the intensity of the heat, not its duration, that defines it. When lightning does leave a mark, it's often subtle. A scorched patch of ground, a tree split along its veins. Sometimes, intricate patterns called Lichtenberg figures, branching fractal burns, appear on the skin of those who have survived a nearby strike. These are the footprints of high voltage. The air itself becomes a conductor. As it ionizes, it glows white-blue, and for a moment, the sky breathes fire. The sudden burst can ignite dry grass, shatter rocks, or even fuse sand into glass, creating fulgurites, root-like structures buried beneath the surface. But again, it is not fire in the ordinary sense. It is too fast, too ephemeral. You could stand where lightning touched seconds later and feel only damp earth. The heat is gone. The sky has exhaled. The moment passed. Lightning's heat is a paradox. Immense, yet fleeting. Devastating, yet invisible moments later. We often think of light and heat as slow companions, campfire embers, glowing sunsets. But lightning teaches us that heat can be a whisper, a flash of brilliance that leaves only silence behind. So, when the next storm rolls in and the sky cracks open, remember this. You are witnessing one of nature's hottest phenomena, too quick to burn, too powerful to hold, just light, and then the cool return of night. During a thunderstorm, most of us instinctively retreat indoors, windows closed, lights low, perhaps a warm drink in hand. It feels safe, protective, and for the most part, it is. But lightning, ever curious, sometimes finds its way inside, not by breaking through walls or roofs, but by following the paths we've built, the ones meant to carry water and electricity. Because lightning seeks the easiest route to the ground, it often travels through conductors. Copper wiring, metal pipes, steel frameworks, all offer it a smooth, welcoming path. And in rare cases, that path leads right into our homes. This is why, during storms, we're often advised to avoid taking showers or washing dishes. Not because it's guaranteed something will happen, but because water, metal, and electricity make an inviting trio. A bolt that strikes a house, or even nearby, can send a surge through plumbing systems, momentarily electrifying the very water we use. It's rare, exceptionally so, but the advice persists, not out of fear, but caution, a gentle reminder that even inside, we're still connected to the sky. The same is true for electrical appliances. Lightning can enter through power lines, riding into outlets and devices. This is why surge protectors exist, to absorb the energy before it reaches something delicate. In old houses, where plumbing is more exposed or grounded differently, the chances are slightly higher. In newer constructions, safeguards are better. But still, we pause, we wait, we let the storm pass. There's something poetic about it, really, that the storm's energy can echo through the very systems we've designed to serve us. A brief overlap between nature's pulse and human design. And then it's gone. The pipes settle, the wires hum quietly again, the lights remain steady. Lightning may have passed close, or not at all, but we listened, we respected its path, and we waited for the quiet to return. For those who survive a lightning strike, the experience can feel like a blur. A sudden flash, a jolt, and then a strange silence. But sometimes, when the moment has passed, the skin tells a story. Fine, fern-like patterns may appear, red, delicate, branching like frost on glass. These are called Lichtenberg figures, named after the German physicist Georg Christoph Lichtenberg, who studied electrical discharges in the 18th century. These patterns are the temporary traces of electricity's passage through the body. They are not burns in the traditional sense. They do not scar or blister. Instead, they're created when capillaries near the skin's surface rupture under the pressure of the electrical surge. Blood flows into intricate shapes, guided by the paths of least resistance, just like the lightning itself. To see one is to glimpse electricity's handwriting. They fade with time, usually within a day, like footprints in snow. But in that brief window, they are breathtaking, a reminder that something passed through, a force vast and ancient, written briefly on the canvas of a human body. Not everyone struck by lightning receives them. They're relatively rare, but when they appear, they become part of the story. And what a story it is. Survivors speak of strange sensations, of silence in the moment, of confusion afterward. The body often tenses, the heart may stutter, memory blurs, but the skin remembers. And for a while, it holds a map, a branching tribute to resilience, to the fact that life continued after the storm. The figures fade, the quiet returns, but those few glowing threads of red remain in memory. Nature's temporary tattoo, an autograph from the sky. In forests and parks, trees stand as quiet witnesses to the weather, season after season, year after year. Their branches stretch upward, their trunks steady, their roots deep. But when lightning visits, even the tallest and strongest can be shaken from within. A tree, after all, is full of water. Its trunk is like a column of sap and moisture, a quiet conductor beneath the bark. When lightning strikes, the energy travels through that moisture instantly. And in that brief instant, the water begins to boil. Steam expands rapidly, too rapidly for the wood to contain it. The pressure builds. The bark shatters outward, sometimes with a sound like a cannon, sometimes in silence, unnoticed until daylight reveals the damage. The result can be dramatic. Trees split down the middle, chunks of bark flung meters away, branches broken, leaves singed. And yet, the tree may survive. Some do. Remarkably, they lose limbs, but keep growing. The next spring, buds appear, flowers bloom, life continues. Others do not. They stand for a time, hollowed and blackened, before falling gently to the forest floor, returning, piece by piece, to the earth they once rose from. There's a kind of quiet reverence in this. Lightning, though fierce, is not cruel. It does not seek to destroy. It merely passes through. The tree happens to be in its path, and afterward, the forest continues. A fox trots past the broken trunk. A bird nests in a cracked limb. Mushrooms bloom near the roots. Life responds. And in time, even the most explosive moment becomes part of the stillness again. A tree that once held lightning becomes a cradle for something new. And the storm becomes part of the wood, far above us and far beyond what we can hear or see. The earth pulses. Every second, every tick of the clock, roughly 100 lightning strikes occur somewhere around the world. Over oceans, across mountains, deep in forests, inside distant clouds. At any given moment, thousands of storms are flickering, sending electric breath into the sky. This global rhythm isn't loud or chaotic. It's scattered, subtle, but continuous. Scientists call it the Earth's lightning frequency, a soft heartbeat of the atmosphere. It's not synchronized, not organized, but it's constant. And just like a pulse in the body, it tells us something vital about the planet's energy. Some of these flashes are massive, others are faint. Some strike the same place again and again. Others flicker cloud to cloud, unseen except by satellite eyes. But they're always there, tiny electric moments that stretch from the ground to the sky and back again. Most lightning happens near the equator, where the air is warm and moist. Places like Central Africa, northern South America, and parts of Southeast Asia see lightning almost daily. These regions act like the lungs of Earth's atmosphere, breathing storms in and out, exhaling light. There's even a spot in Venezuela, near Lake Maracaibo, where lightning happens nearly every night. Locals call it Relámpago del Catatumbo. It's a place where warm lake air and mountain winds meet in just the right way. A place where the sky remembers how to flicker. Each bolt, no matter how brief, contributes to something larger, a global electric circuit. The Earth's surface carries a slight negative charge. The upper atmosphere is slightly positive. Between them, lightning acts like a reset button, equalizing tension, balancing the quiet tug-of-war above and below. This circuit even operates on sunny days. Fair weather still carries charge, and though we don't see lightning then, its echoes linger in the electric field around us. The Earth is never still. It's always humming, always glowing in some corner. We sleep through most of it, but the sky doesn't. Even as we rest, the clouds remember, the storm cells drift, and somewhere the air rearranges itself into sparks. Lightning isn't just a flash, it's a signal, a release, a recalibration. So, when you next lie in bed and hear distant thunder, or see a flicker on the far horizon, you are witnessing one tiny beat in the Earth's ongoing pulse, a rhythm that has never stopped and never will. From above, the storms look soft. Their tops billow like whipped cream across the curve of the Earth. Clouds swirl in quiet spirals. Sunlight glints across oceans and snowy peaks. And in between these tranquil shapes, something flickers. Satellites orbiting far above us are watching. Instruments aboard them, like the Geostationary Lightning Mapper, GLM, aboard the GOES satellites, record each spark, each pulse, each brief breath of light. They don't blink. They don't miss a flash. These space-based eyes can detect both cloud-to-ground and intra-cloud lightning. They see storms we cannot. They watch lightning flicker over open seas, where no one stands to witness. They track electric dances above mountain ranges, deserts, and jungles. From orbit, a lightning flash looks like a glowing coin dropped on a vast sheet of velvet. Some are bright, some are scattered, some occur in long trains, hundreds in a single region within minutes. By watching from above, scientists learn more about how storms form, how they grow, and when they may turn severe. Satellite lightning data helps predict tornado outbreaks. It warns of rapidly intensifying hurricanes. It tells us where the atmosphere is charging up. Before these tools, much of lightning's global story went unwitnessed. We knew it happened, but not where or how often. Now, we can see the planet's electricity in near real time. And there's poetry in that. From 35,000 kilometers away, a tiny sensor captures something as delicate as a flicker inside a cloud. A moment of spark that lasts less than a second, but travels from a storm to space to our screens. At night, the view becomes even more beautiful. The Earth glows in pulses. Lightning lights up storm tops like lanterns behind silk. A planet alive with electric thought. We are used to looking up at storms, but from above, the storm seems peaceful, beautiful, a drifting cloud with light woven into it. So while you sleep, as storms roll silently across continents, the satellites are watching, not to judge, not to fear, but to understand, because even from the cold quiet of space, the warmth of lightning still matters, and the sky always is worth watching. Lightning doesn't just crack the sky, it also quietly feeds the Earth. In the upper air, where clouds swirl and charges build, nitrogen makes up most of the atmosphere. But in its natural form, paired tightly as N2, it's inaccessible to plants. Locked away, it floats uselessly above, unseen and untouched. Enter lightning. When a bolt slices through the atmosphere, its temperature briefly rises to over 30,000 degrees Celsius. At that heat, nitrogen molecules are torn apart, their bonds broken by pure energy. Freed, these nitrogen atoms recombine with oxygen in the air to form nitrogen oxides, NO and NO2. These new compounds drift down to Earth, often dissolved in rain. When they reach the soil, they're transformed again, converted into forms that plants can use. Nitrates, fertilizer, food for roots. The cycle is elegant. The sky strikes, the rain follows, and the soil blooms. Forests that never saw a direct hit still benefit. Grasses drink from puddles enriched with lightning's touch. Wildflowers open above nourished roots. Even distant crops feel the impact. This process is called atmospheric nitrogen fixation. While microbes in the soil also fix nitrogen, lightning provides a different kind, a widespread, weather-borne delivery of nourishment. In this way, lightning becomes part of the food chain, indirect but essential, and it has done so for millions of years, before human agriculture, before machines, Before fertilizer plants, there was only sky, storm, and soil, and in their meeting, life grew. It's easy to think of lightning as destructive, but in the quiet days that follow a storm, when the soil is damp and the air smells fresh, its gifts become visible. A greener field, a faster bloom, a forest subtly revived. Each flash is more than a spark. It is a cycle continued, a reminder that storms can give, not just take, that even the fiercest forces of nature can be gentle in their own way. Lightning is not bound by borders. It does not favor countries or oceans. It has touched every continent, every piece of land beneath the sky. Most often, lightning prefers warm, humid places. The tropics, the equator, places where storms gather easily and air rises thick with moisture. But even in the frozen silence of Antarctica, lightning has been seen. Rarely, briefly, but truly. There, amid snow and sky, where temperatures plunge and sunlight barely rises in winter, the atmosphere still holds charge. And sometimes, when conditions align, a bolt flashes above the ice. These polar lightning events are difficult to study. They happen far from cities, far from roads, in a place almost untouched. But satellite instruments have confirmed them. Bright dots of energy where none were expected. Other continents see lightning more frequently. Africa has the highest rates, especially over the Democratic Republic of Congo and along the shores of Lake Victoria. South America sees regular strikes near the Andes and above the Amazon. North America's Great Plains are famous for summer storms, and Asia experiences massive monsoon-driven flashes. Europe sees lightning too, often gentle, often at dusk, and Australia, with its dry heat and coastal systems, hosts its own electric symphonies. Even remote islands, separated by vast stretches of ocean, have seen the sky light up. This global spread reminds us lightning is universal. No matter where you stand, you are beneath a sky capable of brilliance, of spark, of momentary fire, and whether it happens often or only once in a decade, that flicker leaves a mark. In memory, in soil, in story. Every continent has felt it. Every sky has glowed. Earth's lightning dazzles with its brightness and sound. It fills the air with thunder, splits trees, lights cities. But even our most powerful strikes seem small compared to what happens far beyond our planet. On Saturn, lightning speaks in a deeper voice. Saturn's atmosphere hosts enormous storms, hundreds of kilometers wide. These tempests last for weeks, sometimes months, and within them, lightning crackles like giant drums across the sky. The storms on Saturn occur mostly in a band near the planet's southern hemisphere, known as Storm Alley. Here, warm gases rise, cool, and collapse in dramatic convection patterns, much like thunderstorms on Earth, but larger and deeper. The lightning generated in these storms emits strong radio waves. These are called Saturn electrostatic discharges, or SEDs. They're so intense, spacecraft like Cassini could detect them from orbit. These bursts echo across space in low-frequency tones, not in sound waves, but in energy patterns. The recordings, when converted for human ears, reveal crackles and growls, echoes of distant storms in a gaseous world. What causes this intensity? Saturn's atmosphere is made mostly of hydrogen and helium, with ammonia and water deeper within. The pressure is immense. The clouds are thick, and when they collide and churn, they build monstrous charge separations. The bolts themselves are enormous. Scientists believe some may be over 1,000 kilometers long. Compared to Earth's average lightning bolt of 5 to 10 kilometers, Saturns seem mythic. We can't see these flashes directly from Earth. They're buried deep in cloud layers, but their radio fingerprints reach us, and what we hear is unforgettable. A storm, talking in tones our planet cannot match. It's humbling to know that lightning, something so wild, so powerful here, is but a whisper in the larger chorus of the solar system. And yet, it reminds us we are part of something vast, that even lightning has echoes among the stars. The sky is not just an empty stage for storms. It's an ever-changing tapestry, shaped in part by lightning's quiet touch. Each bolt that arcs across the sky leaves more than just a memory of brightness. It alters the air it passes through, briefly but meaningfully, and in doing so, it shapes the atmosphere itself. When lightning strikes, it heats the surrounding air to extreme temperatures, up to 30,000 degrees Celsius. This sudden burst of heat ionizes the air, stripping electrons from atoms. For a brief moment, the sky becomes a plasma corridor where electricity flows freely through the path carved by charge. This ionized trail doesn't last long. Within milliseconds, the atmosphere cools and the ions recombine. But while it exists, this channel can alter the electrical conductivity of the air. Tiny changes ripple outward, affecting how other charges move. It's like tossing a pebble into a pond. Small waves spread across the surface, even after the pebble disappears. These shifts can influence nearby storms, adjust the local electric field, or even change how future bolts form. In a chain reaction of subtle feedbacks, the sky listens to its own sparks. Beyond the immediate area, these effects build over time. With billions of lightning strikes occurring each year, the cumulative effect is like a gentle sculptor's touch, constantly shaping the atmosphere's delicate balance. Lightning also produces nitrogen oxides, NOx, especially in the upper troposphere. These compounds play a role in ozone chemistry and air quality. While industrial emissions are larger contributors overall, lightning's role is natural and globally distributed, especially in remote regions where human influence is minimal. The shape of the atmosphere isn't just about temperature and pressure. It's also about chemistry, conductivity, and the invisible fields threading earth and sky. Lightning is one of the only natural events that ties them all together. From space, satellites can observe these changes. Instruments like LIS, Lightning Imaging Sensor, and GLM, Geostationary Lightning Mapper, track lightning's patterns and frequencies. Scientists use this data to understand storm behavior, global climate feedbacks, and the intricate dance between energy and air. But beyond science, there's something poetic in knowing the sky responds to its own light, that each flash leaves behind not just thunder, but fingerprints, that the air we breathe is subtly molded by sparks we never see. In this way, lightning is not just a fleeting burst, it's a quiet artisan, shaping the atmosphere with every glow. Across the globe, day and night, over land and sea, lightning flashes somewhere, every moment. It's estimated that more than 1.4 billion lightning flashes occur each year. That's nearly 44 strikes every second. The scale is almost beyond comprehension. These are not just the bolts we see from our windows, but flickers inside clouds, arcs over mountains, and pulses deep within storms that never touch the ground. Some regions see more of them than others. Equatorial zones, especially parts of Central Africa, South America, and Southeast Asia, experience the highest lightning frequencies. There, warm temperatures and moist air create perfect conditions for towering thunderstorms that flash, with regularity. But lightning is not confined to the tropics. It appears on every continent, even Antarctica. It dances over oceans, flickers through volcanic ash, and sometimes drifts silently over quiet deserts. Despite how common it is, lightning remains one of nature's great mysteries. Each flash is a complex ballet of physics, charge separation, electric fields, plasma formation, return strokes. And yet, it often lasts less than a second. A brilliant flicker, then gone. Modern instruments have helped us count these ephemeral events. Satellites in orbit monitor the planet for lightning flashes, gathering data that helps meteorologists and climate scientists understand storm patterns, energy distribution, and even global warming feedback loops. The data tells us something beautiful. The sky is always alive. Even as we sleep, even when we can't see it, lightning is weaving threads of brightness through the clouds, a global circuit of charge and light, stitched together by flashes we may never witness. Think of all those sparks, each with its own path, its own short life, its own place in the sky's memory. Think of how many stories the atmosphere tells in flickers. Some lightning strikes find their way into folklore, others into photographs, but most go unseen. Their beauty lies in their transience, their quiet contribution to the rhythm of the world. So, when you see a lightning bolt, remember, it is one of billions, a single note in a sky-wide symphony, and somewhere, even now, the next one is already beginning. Most lightning reaches down toward the earth, but sometimes, rarely, quietly, it chooses a different path, not downward, but up. From the tops of powerful thunderstorms, otherworldly forms of lightning leap into the upper atmosphere. These are the high-altitude cousins of familiar bolts, ethereal phenomena with names like blue jets, red sprites, and elves. They are delicate and fleeting, barely lasting more than a fraction of a second. But in that moment, they connect storm to space, thundercloud to stratosphere. Blue jets begin deep within the storm's core and surge upward, piercing the cloud's anvil top with a narrow blue glow. Unlike ordinary lightning, they don't seek the ground. They stretch toward the mesosphere, shaped like a thin, electric fountain. Red sprites are more mysterious. They appear higher still, triggered by intense cloud-to-ground strikes. Sprites flicker like jellyfish across the edge of space, red, branching tendrils with soft halos. Some dance in clusters, some flicker alone. All vanish in a blink, and then there are elves, expanding rings of pale light that ripple across the sky's edge, like the echo of a thunderclap in space. They're not truly bolts, but flashes of electromagnetic brilliance caused by distant lightning below. No human eye at sea level typically sees these phenomena unaided, but high-speed cameras, satellites, and observatories on mountaintops have begun capturing them in greater detail. Pilots at altitude have witnessed them too, brief flashes above the cloud deck, so swift and subtle they feel more like dreams than weather. These upward forms of lightning remind us that the sky is layered with mysteries, that not all storms point downward, that even as rain falls, some energy rises, like thoughts ascending, like whispers toward the stars. They happen without thunder, without warning, just flickers at the edge of the world, connecting cloud to cosmos in a hush. So, if you ever lie beneath a distant storm and feel the sky grow still and silent, know that above the clouds something rare might be blooming. Not a strike, but a reach, a soft surge upward, a brush of light on the ceiling of the sky. There are moments when the atmosphere speaks in subtle ways, when something shifts in the air around you, almost imperceptibly, and your body feels it before your mind understands. Before a lightning strike, the electric field near the surface can become unusually strong. So strong, in fact, that the tiny hairs on your skin may lift ever so slightly, especially on your arms or even on your head. This phenomenon is due to static electricity, a buildup of charge in the air. The cloud above is heavy with potential, and when it begins to seek balance, it interacts with everything below, including you. It's a quiet signal, a gentle warning from the sky, not loud or alarming, just a breath, a rising hush. In some rare cases, people have described an eerie calm just before the flash. The world seems to pause. The wind stills. The birds fall silent. Then, the hair on their arms lifts, not from fear, but from charge. It's the earth preparing, the connection forming, the cloud above reaching down, feeling its way. Of course, science advises that if you ever feel this, especially in open spaces during a thunderstorm, it's wise to seek shelter immediately. But here, in our quiet bedtime journey, we observe this not with fear, but with reverence, because this too is part of the atmosphere's delicate language, a whisper before the light, a signal written in touch, not sound. Lightning does not always arrive unannounced. Sometimes it sends a courier, a lift of hair, a tingle in the air, a stillness that says, something is about to change. And then the flash comes, and the sky speaks. From high above, lightning looks different, flatter, broader, and slower. Pilots flying near storms often see flickers that seem to float across the dark dome of the atmosphere. From the ground, storms can seem distant and defined, clustered masses of dark cloud, with lightning dancing within or beneath their structure. But from the air, the story shifts. Pilots cruising at high altitudes, well above the storm layer, often witness a quieter, more mysterious version of lightning, one that seems to drift across empty skies with no clouds in sight. This is lightning in the clear, a phenomenon where distant flashes travel far beyond the boundaries of the parent storm, sometimes more than 100 kilometers outward. These flashes don't crash downward with fury. Instead, they skim across the upper atmosphere, soft, broad arcs of energy that stretch out sideways, like light painting across a canvas of night. Imagine sitting in the cockpit of a commercial jet, thousands of feet above the world. The stars are sharp overhead. The Sith below is shadowed in stillness. Then, suddenly, a wide, pale flash sweeps across the horizon. No thunder, no turbulence, just light, flat and elegant, like a luminous ribbon pulled gently through the air. From that height, lightning takes on a cinematic grace. There's no rain hammering on windows, no loud cracks to startle, just momentary glows in the far-off dark. Pilots sometimes describe these events as silent shows, a slow ballet of electricity playing out beneath or beside them, distant and serene. These flashes are often intra-cloud or cloud-to-cloud lightning events. Instead of diving toward the Earth, they spread horizontally through stratified layers of the upper troposphere, where moisture, ice crystals, and opposing charges create wide highways for the electrical flow to travel. These paths are sometimes invisible, but their result is clear: light that glides instead of strikes. What's remarkable is that these pilots are often flying in calm air. The cockpit instruments show no precipitation, no convective danger close by. Yet still, the lightning reaches across that calmness, a reminder that storms, while localized, have long electric arms that stretch through the skies in unexpected ways. These moments aren't rare for seasoned aviators. Over the oceans, across desert skies, near the equator, or drifting above snowy continents, lightning in the clear becomes a familiar companion. Pilots flying red-eye flights often observe silent flashes below them, clouds glowing softly as though lit from within. It's a gentle, surreal experience, more like watching bioluminescence than a thunderstorm. Sometimes, these sky flickers are accompanied by distant cloud-top illumination. The entire underside of the cloud layer glows, like a city hidden inside the sky. The light diffuses upward and outward, never quite touching the aircraft, never quite explaining its origin, just a pulse, then stillness. For those who fly through these regions, there is a quiet awe in witnessing lightning from above. It's a perspective few ever see. The storms glow without the storm's bite. The arcs and flickers drift without sound, forming constellations that vanish as quickly as they came. And in those moments, there is a softness to it all. The speed of the plane, the hush of the cabin, the gentle navigation of the atmosphere, combined with the presence of something so powerful, yet so quiet. A flicker across the edge of night, reminding us that even storms have their quiet side. Even lightning can be gentle when seen from above. Up here, lightning doesn't always roar. It glides, and in that glide, it becomes poetry. Every lightning strike does more than light the sky. It sings. Long before humans built radios, towers, or antennas, the Earth was already transmitting. Each flash of lightning releases a brief burst of electromagnetic energy, a pulse that spreads outward in all directions. These pulses are called spherics, short for atmospherics, and they travel far beyond the reach of thunder or light. A spheric moves through the air, across oceans, over mountains, and around the curve of the planet. Some fade quickly, others bounce between the Earth's surface and the ionosphere, drifting thousands of kilometers from their origin. In this way, a single lightning strike in one part of the world can be quietly detected in another. You cannot hear a spheric with your ears, but radios can. Tuned just right, they translate these pulses into soft clicks, crackles, and whispers. To scientists and radio listeners, it sounds like rain made of electricity, a gentle static that ebbs and flows with distant storms. Even when the sky above you is clear, the radio may still be alive with these signals. That's because lightning is always happening somewhere. As you sleep, storms flicker across the tropics. As dawn breaks, clouds glow over faraway seas. Each strike adds its own note to a global broadcast that never stops. This quiet radio song is one of the ways scientists monitor lightning across the planet. By listening to spherics and measuring their timing, researchers can pinpoint where a strike occurred, even if it happened far beyond the horizon. It's a form of listening to the Earth itself, using the language of energy instead of sound. Some spherics travel especially far, sliding along Earth's magnetic field lines. These are called whistlers, because when converted to audio, they sound like a descending whistle, as though the sky is gently exhaling. They are slow, stretched echoes of lightning, softened by distance and time. There is something deeply calming about knowing this, that storms do not simply arrive and vanish, but leave behind quiet traces that drift across the world. That lightning does not shout once and disappear, but hums quietly, long after the flash fades. The Earth is never silent, Even on the calmest night, even beneath clear stars, the planet is wrapped in a web of faint radio pulses, invisible threads of energy connecting clouds, continents, and seas. This natural radio music has been playing for as long as storms have existed, long before human ears could listen, long before there were names for it, a constant, patient transmission. So, when you imagine lightning now, you might picture not just the flash in the sky, but the gentle signal that follows, a pulse drifting outward, a whisper traveling the long way around the world, a reminder that the atmosphere is always communicating, always singing, always alive. Sometimes the sky speaks so softly that you almost miss it. On a warm evening, when the air is still and the stars are beginning to show, you may hear a low sound drifting through the distance. Not sharp, not sudden, just a long, rolling murmur that rises and fades again, like a breath drawn by the horizon. This sound has a name. It is called heat thunder. Despite the name, it has nothing to do with heat itself. Heat thunder is simply the sound of a thunderstorm that is too far away for its lightning to be seen. The flash is hidden beyond hills, clouds, or the curve of the earth, but the sound carries on, stretched and softened by distance. Sound travels much more slowly than light, and it loses its sharp edges as it moves. High frequencies fade first. What remains is the low, gentle rumble, rolling through layers of air like waves across a quiet shore. By the time it reaches you, the thunder has forgotten its urgency. You may hear it late at night, when the world has grown quiet enough to notice such things. The sound arrives without warning, without repetition. One long roll, then silence again. It can feel comforting, familiar, like a reminder that weather exists beyond your immediate world, that storms are unfolding somewhere else, unseen and unhurried. In earlier times, people believed heat thunder was the sky cooling itself after a long, warm day. Others thought it was mountains shifting or clouds speaking to one another. Even now, the sound carries a sense of mystery because it comes without light, without rain, without presence. Meteorologically, it is simply distant thunder, but emotionally, it is something gentler, a message carried far enough to lose its edge, a storm that has nothing to ask of you. Heat thunder often travels best on humid nights, when the air allows sound to glide smoothly. The atmosphere becomes a soft corridor, guiding the low tones across fields, rivers, and sleeping towns. You do not need to look for it. You do not need to prepare. It arrives and leaves on its own terms. And in that moment, when you hear it, you may feel connected to something larger, a storm you cannot see, a sky you are not beneath, a reminder that the earth is always in motion, even when your corner of it is still. Heat thunder does not demand attention. It does not warn. It simply passes by. A distant hush, low and long, the sound of a sky that never truly rests. And now, as our journey winds down, may the quiet wonder of lightning, its distant pulses, its skybound shimmer, stay gently with you. Not the kind that startles, but the kind that soothes, that flickers far away, like a memory the atmosphere shares only at night. Perhaps, as your eyes grow heavy, you'll sense a final flash behind closed lids, soft and slow, a brief illumination just beyond thought, not to wake you, but to lull you further, a light without sound, a presence without pressure. These sky stories are here whenever you need them. No alerts, no demands, just calm chapters in the weather's bedtime book. If these sleep weather journeys bring you comfort, you're always welcome to like or subscribe, but only if if it feels peaceful to do so. No rush, no noise. Now, let your breath align with the rhythm of far-off thunder. Let your body soften like the edge of a passing cloud. Let sleep arrive like a warm front settling in, slow and sure. The atmosphere is quiet tonight. You are safe here. You've arrived. Rest easy now. Good night, and calm skies to you.